Sketching absolute value transformations. Let's practice sketching absolute value graphs. Try to visualize each step as we go. We have a function, y equals f of x. In this case, f of x is 10 times the log base 10 of, open parenthesis, x plus 2, close parenthesis. This means the graph is shifted horizontally to the left by 2 units. So, the vertical asymptote is x equals -2. First transformation, y equals f of the absolute value of x. We replace x with the absolute value of x. This makes the y values for positive x and negative x exactly the same. To sketch it, take the right-hand side of the original graph and mirror it across the y-axis, so the graph becomes symmetric about the y-axis. Second transformation. The absolute value of y equals f of x. Now we apply the absolute value to y. First, keep only the portion of the graph that lies on or above the x-axis. Then reflect that part across the x-axis. To say that another way, wherever f of x is greater than or equal to 0, y equals plus or minus f of x. Wherever f of x is negative, there is no real y value. Third transformation. The absolute value of y equals f of the absolute value of x. Here, we combine both transformations. Start with the graph of y equals f of the absolute value of x, the one with y-axis symmetry. Then apply the y absolute value rule, keep the top half of the graph, and reflect it across the x-axis. As a result, the graph in the first quadrant is reflected across the x-axis, the y-axis, and the origin. But symmetry isn't always just about the x-axis, the y-axis, or the origin. Let's think about absolute values that create symmetry with respect to a vertical line, like x equals k. Let's go back to our specific function, u equals 10 times the log base 10 of, open parenthesis, x plus 2, close parenthesis. It has a vertical asymptote at x equals -2. Now, if we insert an absolute value around x plus 2 inside the logarithm, we mirror the graph across that vertical line, x equals -2. Fourth transformation. y equals 10 times the log base, 10 of the absolute value of x plus 2. This gives us 2 branches that are mirror images across x equals -2. Here's an important domain note. The expression inside the log, the absolute value of x plus 2, must be positive, so x cannot equal -2. Fifth transformation. The absolute value of y equals 10 times the log base, 10 of the absolute value of x plus 2. Now we keep only the part of the graph where the right-hand side is non-negative. That is, where the absolute value of x plus 2 is greater than or equal to 1. Then reflect that part across the x-axis. In other words, y equals plus or minus 10 times. The log base 10 of the absolute value of x plus 2, but only where that expression is non-negative. Let's summarize. Adding an absolute value on y folds the graph upward across the x-axis. Adding an absolute value on x mirrors the graph across a vertical line. Across the y-axis, when it's just absolute value of x, and across x equals -2, when it's absolute value of x plus 2. So remember, use the ideas of fold up and mirror to sketch these graphs quickly and accurately.